Hi, in this video, I'm going to go over the code of scale down in Cluster Autoscaler. I'm not going to cover all the details, but I hope it gives you a good understanding of how scale down works in Cluster Autoscaler. This right here starts our, it runs a for loop, which updates the cloud provider cache. Cloud provider cache has two things: node groups and the instance, the cloud provider instance. Node group in this context is a concept limited to Cluster Autoscaler. It has no relation with EKS node groups. So if our cloud provider is GCP, that is, if you're running this Cluster Autoscaler in GCP, a node group would be a managed instance group. If you're running the Cluster Autoscaler in AWS, our node group would be an ASG, that is an autoscaling group. This is a for loop which runs every 10 seconds. You can configure it to run for some other time with a flag. This is where scale up and scale down happens. If scale down is enabled, then we go into the scale down code. This can be disabled using a flag passed to Cluster Autoscaler. It is enabled by default. We get the scale down candidates, and the way we do this is we get all the nodes, and we remove nodes which cannot be scaled down further. For example, if there is an ASG which has the minimum node count as 2 and maximum node count as 4, and the current node count in the cluster is 2, that there are already 2 nodes in the cluster, scaling them down won't work because it would go beyond the minimum size of the ASG. We drop such nodes and we add scale down candidate nodes from last iteration, and we sort them so that the scale down candidates from the last iteration get first preference. Scale down actuator and scale down planner are two important constructs in context of scale down. Scale down planner is what we use for planning a scale down. Scale down actuator is what actually implements or what actually scales down the nodes. Update cluster state updates the cache for scale down, and one of the things it does as a part of updating that cache is figure out the unneeded nodes. The way it does this is by performing some checks. The most important check in this is where it takes off as a simulation, it takes off pods from a node and sees if it can schedule somewhere else. If the pods can be scheduled somewhere else, it means the node in question is unneeded and can be removed. We can access the unneeded nodes using .unneeded nodes function of scale down planner. We further split the unneeded nodes into empty nodes and nodes which need training. Empty nodes are nodes which have daemon set pods, but no other pods. Nodes which need train have pods other than daemon set pods. This is where the actual deletion happens. And we have this function on scale down actuator because that is the function that performs scale down. It deletes empty and nodes which need training. And once the scale down is finished, we recalculate the cluster state registry. Cluster state registry is a global cache which represents state of a cluster. If there were no unneeded nodes and no nodes were deleted, and we have max bulk softained count enabled, we get the nodes which are unneeded from scale down planners, and we get the nodes which are needed, and we taint the unneeded nodes using a softained, which autos softained that we apply to mark these nodes as scale down candidates, and we add a prefer no schedule taint. To go a little deeper into how the actuator deletes nodes. The max number of nodes that can be trained at any given point of time is set using parallelism, a max train parallelism. And based on that, we decide how many nodes we want to train. So for example, if the max parallel node train is 4, and if 2 nodes are already being trained, and we have identified that we need to train 3 nodes, but since the budget only allows 2, we decide to train only 2 nodes. If the node is empty, taint the node with a no schedule taint. This is different from prefer no schedule taint, which was for deletion candidate. This taint is for deleting the node. For an empty node, we go over all the nodes, and we once again check if there are any pods on the node which need to be moved somewhere else. Get for deletion on node train is to check, like the name suggests, it get pods for deletion when we are training nodes. But since we are looking at an empty node, what we are trying to check is if there was any pod that was scheduled on an empty node after you mark node as empty. And if there was, and we also check PTPs, ideally there wouldn't be a pod, node infrared pods in the first place. It would be empty, but just in case it is, so this function wouldn't be run if there were no pods. But if there are, then we would get some pods and daemon set pods and some blocking pods. And we also set no PDBs, but just in case, we check for PDBs. And since there are no PDBs, this is empty for an empty node, this function won't be run anyway. So we wouldn't be getting into this code block at all. Now, if there are any pods which are not daemon set pods, a normal pod, then we say the node is not empty. So scale down is stopped for that particular node. And then we go on to the next node. But if the pods to remove are 0, there are no pods that need removal, and a node is in fact empty, then we schedule deletion. We add it to something. We add a node to node deletion batcher, which deletes the nodes in a batch. And this thing drains the node. So since we are not trying to drain the node, it's an empty node. We just evict the daemon set pods, and the node is set for deletion. And then we call the add node, which deletes the node from Cloud Provider. Going back, so this is how deleting empty nodes work. Deleting non-empty nodes is very similar. We call the same function, except we now also get the PDBs, and then we run the same get pods to move function, and we find the pods, the daemon sets, and blocking pods. Pods here are pods which can be scheduled on other nodes. Blocking pod is a pod which cannot be scheduled on other. So an example of pods which can be scheduled on other node would be a deployment / replica set pod, a stateful set pod, a pod which is replicated. A blocking pod can be a standalone pod which is not owned by anything and which cannot be scheduled on any other node. And we check the PDBs. If there is a PDB which blocks moving the pod, then we throw an error. And we return this error right here. Now, if get pods to move throws an error, we skip the node for deletion and draining and deletion. And this is where we schedule the deletion. Now, since we are draining the node, we are going to drain with pods, which is to say we are going to drain both daemon set pods and normal pods. This is the function which does the draining. It evicts normal pods and it evicts daemon set pods. It does it by sending an eviction request. And then it adds it to deletion batcher. If deleting interval is 0, it removes it immediately. Otherwise, it removes it after some time. So back. So this is how deletion works. As for scale down planner, no so delete. Let's look at that. A resource limiter, we get the resource limiter, which is basically, so this part of the code is basically checking if we are not scaling down, then the minimum quota of the cluster. We're not scaling down too much. And if there are any pods to reschedule, then we say that nodes need a dream, otherwise we add it to empty. And we get this node to remove by from scale down set get nodes to remove. Note that get nodes to remove is not doing much. It basically ensures that the nodes to remove are capped at a max count. They are not exceeding a max count, and if they are, then it caps them at the max count. The max count here is the max scale down parallelism. That is how many nodes can be drained in parallel, how many nodes can be drained parallel at once. Note that this is very similar to what we did in Actuator. And then eventually we return empty nodes and need to drain. And then we pass them on to start deletion. And that's all. Thank you for watching.